Hello, in this video we are going to discuss how to use dummy variables if you suspect that effect on one variable on the other variable might be different for two or more groups of respondents. So we will discuss this problem based on the following hypothetical example. It's hypothetical because some time ago I planned to make a research on this topic and I never had a chance to collect a good data set. So if you feel like exploring this topic, please feel free, no problem. So in this model, wage stands for the dependent variable. We assume that wage is affected by gender and number of kids. So the intuition is very simple. It's affected by gender because of gender discrimination, and it's not something I personally believe in. It's based on very extensive research in this area. So yes, this effect exists. And number of kids is due to the fact that if a worker has kids, then the worker is able to spend less time on education, training, and work. So that's why we hypothesize that number of kids affects wages negatively. What we are interested in is the product of gender and number of kids variables. So gender is a dummy or a binary variable which takes the value of 1 if respondent is male and the value of 0 if the respondent is female. And number of kids is cardinal discrete variable. It's cardinal because 4 kids is twice as much as 2 kids, and it's discrete because it's not possible to have 3.2 kids or 2.5. It has to be the whole number. So that's why it's not a continuously distributed variable. So the product of these variables would indicate the effect gender causes on the effect of number of kids on wages. It will indicate the difference between effect of number of kids for males and effect of number of kids for females. And if you'd like to ask why we are discussing this, is because it makes sense. So females are usually responsible for children. They bear the major proportion of childcare responsibilities, and that's why for them this effect is more significant. At least hypothetically, like this is what intuition tells you. Of course, checking this hypothesis would require collecting some data, and we have no data. So in this Excel spreadsheet, you can see some hypothetical example, like how would you structure this data set if you actually have some data. So income is just the continuous variable, it's our dependent variable. Gender is a dummy variable which takes the value of 1 if respondent is male and the value of 0 if respondent is female. So the coefficient of this variable would indicate the difference between expected earnings of males and expected earnings for females, not vice versa. So the variable takes value of 1 if the respondent is male. That's why it indicates the difference between males and females, not females and males. Like, this is important. So number of kids is just number of kids, nothing to discuss here. And this is the product of gender and number of kids. So if the respondent is male, then it's the product of gender and number of kids, like 1 or 3 or something. And if gender variable is equal to 0, like the respondent is female, then the value of product naturally takes the value of 0. I know this is very intuitive, but yeah, I'm very sorry for over-explaining this. Okay, so if this is clear, then in this case, the value of dummy variable will affect not only the value of intercept, because we include gender dummy as a separate variable in our regression. So if we assume that gender has positive and statistically significant coefficient, so males indeed earn more than females, then the intercept for males will be located here. Like, we expect that the sum of beta 0 and beta 1 is bigger than beta 0 because beta 1 is positive and statistically significant, at least in our hypothetical example. So if our intuition is correct, and females are indeed affected more by the number of kids than males in terms of their income, then beta 3 shall be negative and statistically significant. So this will mean that for males, effect of kids is less powerful than for females. So if this is true, then the coefficient of this regression line, like in our case, we have beta 2 in front of number of kids. So if we analyze male workers, then we will have to add beta 2 and beta 3 in order to obtain the effect of number of kids on male workers. Again, beta 3 is negative. That's why the value of slope here is smaller in comparison to females. So in our case, beta 2 will be bigger than beta 3. Again, if beta 3 is indeed negative and statistically significant. That's why for females, income will decrease faster depending on the number of kids. Like, you can compare the slopes of those two lines. Like, the slope of line would indicate the loss of income depending on the number of kids. So if our intuition is correct, then for females, income shall decrease faster depending on the number of kids than for males. So more or less, this is how you can use dummy variables in order to analyze the difference between the effect of one variable, number of kids, on the other variable, income, depending on the group the respondent belongs to. Okay, so I really hope you enjoyed this video, and in the next one we discuss how to use dummy variables when we have more than two categories of respondents.